Okay, we're back. Part 3, finally. It's taken a while to get through this. Okay, on this one, if you multiply both sides by x squared over x is just an x, and you have a negative, so that's how we ended up here. This is just simplified. Now, if you plug a 0 in, you can clearly see it's 0, so natural log of y is 0. Is 0 the answer? I hope you said no. Remember, we're trying to get y. There's really an e here. E to the 0 is 1. Now, finally, we're there. 1 is our answer. You're not going to pick 0 and fall into the multiple choice trap. Okay, kids, going on. Let's use this one. Look at this problem and what comes to mind. 5, 4, 3, 2, 1. Yep, second fundamental theorem. We have an integral here. We have a variable up here. We have a function in relationship to a non-x. In this case, it's t. A lot of times it's t. We don't have to use second fundamental theorem, though. I just want you to be able to look at this form and think about that. So let's figure out what we would do. Direct sub, plug a 1 in. If you integrate from 1 to 1, you're going to get 0. If you sub a 1 in here, you're going to get 0. 0 over 0 is indeterminate. So we are using L'Hopital. So now for sure it's second fundamental theorem, because if you take the derivative of the integral, remember, it basically undoes it. X goes in for t. And what do you multiply by? Derivative of the top, which is 1, over 2x. Always try direct sub first. Don't try to go to L'Hopital right away. We did it once and it worked. Let's try it again. Cosine of 1, that's not on the unit circle. I have no idea what that is. 2 times 1 is 2. There's our answer. Okay, on the back. I believe this is an old FRQ, so this is awesome practice for us right now. On this first one, looking at this DiffEq. So we're thinking chapter 6. So looking at this and thinking of chapter 6, they're asking for the derivative, the second derivative in terms of x and y. Remember, a lot of times from this chapter, if they just say x and y, that means that's all we want. So this derivative looks like this. Let's make this 2 look more like an exponent. Okay. The derivative of y squared is 2y. Don't stop there. What rule is this? Implicit dy dx minus 1/2. This is what I meant by if they want x and y, don't stop here. Dy dx is this, and we can sub it in. So now we get 2y, y squared minus 1/2 x minus 1/2. Now we can stop here. This is fine. So if you want to keep simplify it, go ahead. I'm going to call it a day, and we're good. Okay, there's a couple free points. Going on to B, let f of x be the particular solution. Let me zoom out a little bit. This is a little wide. To the DiffEq whose graph passes through the point 2, -1. Do we have, oh, now it's blurry. So do we have a relative max, a relative min, or neither at this point? So let's go back and think about what it means to be a relative max and relative min. What is the first thing you would find? 2 words, one starts with C, one starts with N. Critical numbers. So what is a critical number? It's when the derivative is 0 or does not exist. So let's see what's going on with dy dx at 2, -1. We have dy dx above. It's y squared minus 1/2 x. So y squared minus 1/2 x, which gives us 1, x was 2. 1 minus 1 is 0. So we do have a critical number. So this guy is potential. That's what we're saying. So now we want to know what it is. Now, normally when we had a relative max or relative min, we would make a sign chart and we would say relative max if the derivative, so f prime, let's use in this case, goes from positive to negative. Relative min, if f prime went from negative to positive. But look at our derivative now. We have 2 components. We have an x and a y. So that methodology kind of goes out the window because we can't just look at x to see if f prime is changing sign. But there's a second rule. So first derivative test doesn't work, but remember the second derivative test. The second derivative we have right here. So let's go ahead and sub a y of -1 in and an x of 2. Let's see if all this looks right. So 2 times negative, negative 1. Good. So then we're going to have, oops, negative 2. And then this is 1 minus 1. Oh, that's great. So now we get negative half. So why do we care if the second derivative is negative? Remember, if the second derivative is negative, that means the function is concave down. So let's go over to this space now. We have a little more space on this problem. So f has a relative, and I'll fill this word in a second, at 2, negative 1, because f is concave down. And really, we're done. We're really okay here. I'm adding this as an explanation for you. Think about concave down. What is this? Relative max. Okay, again, first derivative is probably our go-to. I need you to know why it failed, and it's because our derivative had a y in it. So we couldn't just test x on either side. So then second derivative came to help us out. Okay, looking at C, guys, we're almost done. I know this has been a lot. Let G be the particular solution to the diff EQ. Remember, particular solution they gave us an ordered pair, negative 2, 3 to the right. Find the limit of this. So limits, the first thing that we're going to do is direct sub. So let's write what we're doing. Sorry, we're off the screen a little bit. Okay, so if you sub in, remember we're looking at negative 2, 3. So if you sub a negative 2 in, you're going to get g of negative 2 minus 3. 2, negative 2 plus 3 cubed minus 2. G of negative 2, it tells us in this problem that the answer is 3. So 3 minus 3 over 2 minus 2, 0 over 0. Okay, what does that mean? That means indeterminate. What are our choices? Think of your 3 algebra. Factor, rationalize the numerator, and what's the third? Combine like terms or common denominator. None of those are working here. So who's coming to help us out? L'Hopital, or really Bernoulli. So now, remember, you're allowed to take the derivative of the top and bottom independently. It is not quotient rule. So the derivative of the top becomes g prime. The derivative of the bottom, let's use chain rule here. See how it's binomial raised to a power. Bring the 3 down. You get 6x plus 3 squared. The derivative of the inside is 1, so we're good there. The derivative of 2 is 0. Now try direct sub. So g prime of negative 2. 6, negative 2 plus 3 squared. G prime of negative 2. How are we going to figure that out? Okay, we'll have to think about that. But we know the bottom is 6. So this is going to take a little more work. Let's think what they're saying. G prime is y. And don't we have dy dx above? Go look back in the beginning of the problem. They told us that dy dx is y squared minus 1/2 x. This was given in the beginning. So now what I want is the derivative, because they said y is g. So I can take g prime, which is dy dx, and I want it at negative 2. But negative 2, if we go over here a little bit, do you see that there's a y in here? Negative 2 is at 3. So instead of just looking at x, we actually have to look at negative 2, 3, which is 3 squared minus 1/2 of negative 2, which is 9 plus 1, which is 10. Sorry, keeps going off the screen. So this is 10, so then we can come back here and write 10, reduce this to 5/3, and we're good. Okay, last one. So y is now h. So y is h is the particular solution to the diff EQ when h of 0 is 1. Use linearization. What we're doing is, remember, if we had this, and this is just a review for you, and if I want this, but I don't have access to the function to get this point, but I do have this point, and I do have access to the tangent line, what we would do is we would plug this x value in to approximate what this value is. That's what this is talking about, linearization, tangent line. They give us the ordered pair 0, 1. It says that all the way to the right in the first line. So if we have 0, 1, we know that we can start subbing that in. We're going to have to figure this out. but there's our 0, 1. This is the derivative of h at 0, 1. So think about how are we going to find the derivative of h when we don't have what h is? Well, look what they told you here. H is y, and we have dy dx. So dy dx, remember, they gave it to us in the beginning, is y squared minus 1/2 x. We want dy dx at 0, 1. So we have 1 squared minus 1/2 times 0, which is 1. There's our derivative. So this is the derivative of y, but because y is h, it's also the derivative of h at 0, 1. Here's 0, 1. Here comes a 1. There's our tangent line. Now remember, the approximation is we want the curve value, we use the line to approximate. So we're going to use this approximation to see what's going on when h is 1. 1 is the input. So now the input gets replaced with 1, which makes y 2. So h of 1 is approximately 2. And that's a wrap for 8-7. At this point, that's everything that you guys will need for the AP test. And best of luck reviewing.